Okay, I am live. Sound checking. I'm trying with this clip-on mic, and I think the last time I wore it, I was way louder than everybody else. So if people could give me a sound check. Tell me if I'm too quiet or too loud. If I'm really excited, I'll probably say something like, "Yay, it's working!" Okay, Sylvan says he can hear me. Okay, so I'm going to try to do a bit of streaming, which I'm not used to, but I saw one of BitLooney's recent videos that was inspirational. You're an inspiration, BitLooney. And he does a lot of streaming with his audience and working on projects as he's going, and then cuts them up and puts them together to a YouTube video. And the having the bits from the live stream is a really nice way of having more kind of interaction, and also getting a little bit of that excitement through when you do something for the first time. Okay, and it's not clipping when I scream. Good. Yep, so Tiny Tape 06 chips. We actually got them back a little while ago, but I was in the US. There were some delays at the fab, so we got them a bit later than expected. They're now being assembled. So if you're watching, you won't have your chips yet, but you should receive them in a few weeks. The mass production is in full flow right now. Took us a while to get the tests and stuff all sorted out with the new changes with the software development kit. But I just received my chips this morning. Sylvan got them while I was away. So he's already tested them. We know that they work. So if you're following along on the Discord channel, you already know that things are looking good, including the analog projects, which I'm really excited to check some of my own projects. That's my first mixed signal on Tiny Tape 06. So Sylvan's going to join us later on, maybe like in an hour, to look at the analog stuff and do a bit of characterization on the analog path. And my plan now is to check whether the chips I've got are working. Have a look at the absolutely massive. I'm going to have to upgrade to the bigger spiral binding next data sheet probably. Choose some of those designs, try them out. And I've got a little a stamp as well. So if the design works, I'm going to stamp it. We've got the QFN socket. I think you should be able to see that here, the black thing up there in the kind of top center on that feed there. See if that works. We had a mix up with some wires on the carrier board. Like we updated the demo board and then forgot to update the carrier board or something. I'm not quite sure what happened there, but that went wrong. So I had to do a bit of soldering there. So hopefully that will work. So I'll try that first. We'll see if we can connect to the chip, try out some of these things. And then I've got another chip already soldered up with the UF2 connectors, and the pink kind of board there on the left has got the SMA to UF2. So I'm saying UF2, but I'm wrong, aren't I? That UF2 is the name of the Python SDK image for flashing onto the RP2040. It's the UL2 or something. Sylvan just corrected me earlier. What is it? What are they? U.FL. Don't know how you say that. Yeah, Sylvan's chiming in the comments as well. UFL. These little kind of, maybe I'll try and get this board a little bit closer. So this is what we've got prepared for the analog testing. So we've got those 12 little U.FLs on there, and they're ready to go with the test board for me to plug it in. And then I've also hopefully going to be able to show off some fancy scope stuff. So I got given this amazing scope by Daniel at Keysight. So hoping to show off some of that working as well later when we check out the analog projects. But I think to start with, I'll just try putting this QFN chip in and then connect to it with the Commander interface and try a couple other projects. So that's going to be the first thing. I'm going to unplug this first, actually. Okay, no fire. Nothing on the display there. Sorry, it's a little bit hard to see that. Maybe I can deal with the... It might make it easier to see if the lights come on. But first thing will be to share my screen here, and then let's get a tab up. So cutout clips is asking how many projects in total. We go to tiny tape out. Actually, that's a good question, because our index actually at the moment isn't great, because these are the MUX indexes, and if you get like a big project that uses a lot of tiles up, then it uses a lot of numbers up. So we don't have 975 designs on there. Actually, can't remember, and that's something that we should probably fix to make it easier to do that. It was out to date. It was our best up until Tiny Tape Out 9. Tiny Tape Out 9, we actually managed to fill it even a little bit more. But yeah, 6 is also the exciting thing about 6 is it's the first one with the analog. Okay, so Sylvan's saying, don't forget I need the new Commander, but I think it's just, I don't need to append anything here on the URL. I just need to connect to it. I've got another one on my desk, so it's not that one. So I connect there. Shuttle unknown, that's not a good sign. So if it's working, it should read what the shuttle is, and then give me a list of all the projects here. So the reading of the ROM has not worked with that QFN socket. Might need to update the bootloader though, so I'll just do that. So the way you do that is you press down the boot button and then plug it in. And then it's going to come up as a USB device. And then download the UF2. All right, this is the UF2. So Sylvan, maybe you can tell me how I get the new Commander. Do I have to like append something to the end? It's good anyway, so I can show how. to update the firmware. You just drag and drop it. That's the awesome thing about this USB class compliant stuff. Does take a little while to copy over. There's a whole new link for this. Thanks, Sylvan. Refactor. Oh, okay. So I think this is to do with with the SDK work update. Now that it used to be that we kind of had the same code base in both the commander and the SDK, and it's now been refactored so that the commander just talks to the SDK that lives on the RP2040. So that's now been updated. Let me just replug this then. And then we'll try to connect to the board again. All right, that looks better. Maybe. No, it doesn't. Just get stuck on read ROM. Shuttle unknown again. Nothing. Oops. Detected tiny tip at 6. Demo board, no chip ROM here. Okay, so that is not working still. TT04. Try one more time. No. Okay, well, I guess that might well be the sockets. Maybe I messed that up, or the chip's in the wrong way around, or any other things. So I'll try with the other board that I got soldered up. Hopefully that will work. These things are super useful if you're going to be taking on and off the board, because it's very difficult to get it out without bending the pins. So these make it a little bit easier to take it off parallel. Oh, that looks a bit better. Don't know if you can see that. Yeah, that looks much better. Oh, it started doing something already, which you can't see because I just realized I took this stream off. Oh no, it's there, but it's maybe, could be bigger. If I remove myself from the layout, does the sound go? Okay, yeah, thank you, Daniel. So it's a little bit difficult to see. Can I, it makes it a little bit bigger there. Yeah, so hopefully you can see the LED is doing something. So I've got something wrong with that QFN. I'll leave that for now. Let's try this again. Okay, that's good. So it's detected the TT06 shuttle. So what happens when it connects up is it reads the ROM from the chip. So in every chip, it's always this first project, project number 1. I just don't know where that is on the map. We'll click it. We should be able to see it. There it is, right next to the controller. And basically, we just encode some information. One of the things I love about it is we encode the git commit hash of the thing that we actually taped out. So it's great to have that kind of transparency and being able to read and see inside. So we dump out that, the shuttle, the repo, the commit, and then the commander knows where to fetch the information from. We have a simple API that lets you get all the projects. So now it's read all the projects and it knows what is in there. And we've got all of these things now. We can load them. So first thing to check is the factory test, which is probably the one that's actually already running. So I can select that. And then we can go to interact. And is it the pinouts? There was before a way to click on the repo, go straight to the repo. Seems to have gone in this refactor. Oh no, there it is. I'm just being not able to read. So now we can look at the source. This actually might have the documentation here as well. So if select is high, counter is output on the output pins. So that is input 0. So we should be able to come here and set input 0. I can see there's nothing happening yet. That's probably because there's no clock running. So I set that to 10 kilohertz and start it. Okay, now you can see there's something's coming on there. Maybe I'll just turn that off again. So I should be able to clock it once like this. All right, and then hopefully you can see on the screen every time I press it, we're getting a new count. So that's great. So the factory test works. So I can report results and say, just check the counter. It works. Hurrah! All right, so I had a little look through some things I thought might be interesting to test. Let me see if I can find. Here we go. So I've done the factory test. Now hold on, let me need to give it a stamp in the book with my stamp. Tested. All right. So let's have a look at one of these other ones. 7-segment fun by Armin Hartel. Different animations on a 7-segment display. default settings should display number 0 to 9. So let's enable that. Fun. Select. You can see it's showing a 0. Oh, now it's counting. There you go. Am I now? Can you hear me now? I've just done something different on StreamYard, and it's still giving me the option to remove myself. So maybe I'm on, but maybe it's kept the sound this time. If someone can tell me if I've got the sound on. Yeah, cool. Thank you, Daniel. And yeah, Daniel, I do have a VGA monitor, and yeah, I can plug it in a bit. So let's take another look at this. And by pressing the default, we should change every second. The design can be, okay, so it's changing every second. Different input buttons and seeing if the speed, respectively, the animation changes. So we've got button 1, 2, 3, and 4 to increment the animation or increment the speed. And that should also be given here on the pinout. Yes, cool. So you can go to REPL, that's still in. So let me put this back up. Can I do them like side-by-side mode? But kind of want the screen to be shared. I want the screen to be big and the thing to be big, the display down there. Anyway. Okay. That looks like it's doing words now. What's it saying? Maybe that's his name, their name. Okay, and then I'll try another, I'll press that button again and switch on to the next animation. Okay, now it's chasing. Let's try the increase the speed button. Which was it? Pinout. Increment speed, button 3. No, button 2. I'm pressing that button many times. It doesn't seem to be doing anything. Let's try a different animation. Okay, now it's going backwards. Now it's 2 segments chasing each other. I mean, one way you can get it to go faster is by increasing the clock speed, I guess. Let's try it at 25 megahertz. Yep. Maybe these need to check the source, but maybe the increment and decrement speeds are, they're just increasing by 1. And because it's doing a 10 million divide, you'd have to press it many millions of times to make an impact. So that kind of thing might be better done with a REPL. Hello, Hayri, from Ankara. At the moment, I'm testing 7-segment fun. Okay, so that's cool. Let's me report results on this. Yes, checked a few animations, got your name and the following segments. I couldn't see any change with the speed buttons though. Okay, so let's come back here. Done the factory test, done 7-segment fun. Let's try, okay, I think with this one, I'm gonna need this is one from Harold Prettel, time to digital converter. And it's going to need a little bit of setup on the. I might come back to that one actually. Let's try this walkway design. Even or odd numbers. Okay, I think when I checked this before, no matter which number turns on, the LEDs will not light evenly. So this is design here. So we can simulate it here as well. So it's not quite what I expected. But we can maybe see if it matches. Two, 4, 6, and 8. Oh, okay. So 2, 4, 6, and 8. All right. Yeah. Okay. So let's try that then. Play with numbers. Select. Okay. Now let's remove that so you can see. I would like to be able I apologize for my terrible streaming skills. I try to get better at it. I just saw in the comments sound was muted. Yeah. If I take myself from the stage, so if I do a solo layout now, full screen layout, you'd be able to hear me because I'm still on the stage. All right. So the thing I'm trying to say is this is how it should be wired up. And this person has, for whatever reason, done like a completely different style of wiring. So we're not going to see, it's not going to match up with the walkway. But I should be able to, we might be, if I change these, the interact here and set to like 2, 4, 6, and 8 up, then we may see something change on the display there. So now I will bring this back and set 1, 3, 4, and 7. Oh yeah, okay. So yeah, when that last one goes, and then let's try the other way around as well. 0, 2, 4, and 6. Okay, so it does seem to respond how they're expecting, but because of the wiring is different, it doesn't look like how it does in the walkway. So I'll just report that. Does detect the odd and even switch settings, but the display doesn't match walkway simulation because the 7-segment display is wired differently to how it is on the board. I would like to zoom to the board, but I'm concerned that if I connect anything on Linux to that webcam, it's going to mess with the colors, because that's what happened last time. Then I had to reboot into Windows to reset it. I can try to make the camera closer, but I'm not going to try to zoom because I'm sure that will break it. And I don't know how well the focus will be. I realize I'm talking again, but because I'm removed from the stream, you can't hear me. So can I get this, make this bigger and that smaller? Okay, that's kind of, maybe that's a bit better. can see the board. Maybe I'll try this zoom thing. It would be better, wouldn't it? Doesn't let me control anything now, though. There we go. User controls, camera controls, zoom. Ooh. Okay. So that's possibly a bit better. Okay. So yes, so check this one. Okay, let's try Uri's oscillating bones. I'm really keen to have a look at this one. Look at this crazy layout Uri did. So yes, for anyone that doesn't know Uri, he's got a bit of a skull fetish. And like he's always been into these skull decorations, and then he got into doing MOSFETs in the shape of skulls, and then he built an inverter out of skulls. So this is inverters made out of skulls laid out in a circle. So it's a big ring oscillator, a simple yet stylish ring oscillator. Collector scope to OSC out, and this is still a digital project. OU out pin 0 and enjoy the show. Okay, so let's try selecting it. Bones. Select. Don't need any of this, so you should just be able to see that on output pin 0. I guess we would potentially see a dim glow on the 7-segment display. So I can see that. I don't know if you can with the once I move the light away. See, the bottom segment is the strongest, and then the next one up from that is a little bit brighter. So let me get the scope on the case. Should maybe have soldered some headers on here before I started. Oh well. And let's try this scope with auto. Already got something. Not exactly what I was expecting. Let's just try with that one. That should be easy. That's really not what I'm expecting there. That looks better though. And what have we got there? Measure frequency. Need to enable the screen. Okay, so that is giving about, well, that looks like it's skipping that middle one for some reason. So, but it's measuring 22 megahertz there, but it's actually double that. So it's around 40 megahertz. That one is 20. So we're meant to be if we look at Uri's design, I should also be able to get a screen capture of the scope here. Or not. Get image. There you go. So, yeah, that's output 0. It's definitely not a square wave. And then we should get 2, 4, and 8 divided down. Let's take a closer look. Not in the GDS. Actions. It would be nice to. They're expired, unfortunately. Okay. So he's expecting the second divided one down to be 20 nanoseconds, which is 50 megahertz. And we're seeing about 20 megahertz, so a lot slower. And oh, that's actually the third one down. So that's this one. So he's expecting about 44 nanoseconds. 22 megahertz. All right, that's pretty close then. That's good. Very good. Then we get the faster one here, but a very distorted output, which I guess is we don't expect a very great bandwidth for the digital outputs. It's kind of around 40 or 50 megahertz. So maybe that is why this first one looks so bad. You bring that trigger down. Okay. Yeah, so maybe that's kind of expected then. That auto measurement is really not liking it, but we can divide that by 2 and get around 10 megahertz. No, I mean multiply by 2 to get 40 megahertz. For this one here, and that looks like it's about a 10 nanosecond. Period, which we're definitely not seeing 100 meg, but I guess that's not what we wouldn't expect to see much there though on the output pins. So let me report results. Partially saw decent waveform at the third output pin. First 2 look pretty bad. Also would be great to have the expected frequencies listed as well as the graph. Okay. Well, that's good. Anyway, it's great that it's doing anything at all. I mean, we are seeing more stuff working, but it still kind of sometimes surprises me that we're actually doing this and it's working. Okay, so somebody wanted video stuff. So we've got Flappy Bird here. I'm not sure. Waveform test. Oh, this is with an LED matrix. Okay, this is not video. But if we enable this, we should still be able to see the outputs doing something. Oh, we've got Silvan in there.
Hey, hi.
How's it going?
Good. So what have you done? I've missed like the last 30 minutes or 20 minutes, something like that.
I was just checking Uri's oscillating bones.
Oh, yeah, okay.
Which does oscillate, but it if I load up the if I get a screenshot here, this is what we're seeing on the it's taking a bit of a time to refresh the image. The undivided, wow, that's just awful. That's the what's coming out of output 0.
Okay. Yeah, but wait. So where is your horizontal timescale here?
And Uri was we're expecting a 10 nanosecond period.
Yeah, so the outputs 100 megahertz are not gonna behave very well.
No.
So that's sort of expected.
No, but the first second division, the orange line here was very close. Actually, I might just, while I've got the design working, let me move that probe across again. I don't know if this is my network or the scope or what.
Is it in
There we go.
Wi-Fi or something?
Yeah, it is on Wi-Fi. Yeah, that's how I got it connected to the computer. I guess I could try with a cable.
Yeah.
Um,
Okay, so that's the 21 megahertz. Yeah, that looks more or less what I'd expect. I'm not
Yeah.
sure. You know, okay. Obviously, there seems to be some a lot of jitter. So like the oscillation frequency isn't super stable.
Yeah.
You probably won't see on the screenshot, but I'm guessing like even if you just press on the ASIC. Yeah, but your desk is far from the thing, isn't it? Or...
I was hoping I'd be able to upload a picture here, but I unfortunately can't. But I can at least send Uri this picture.
That's something that would be useful in the feedback. Definitely is the ability to protect it, because you can put links and stuff, but you need to host it somewhere, right? So.
Anyway, that is really extremely slow. I just take a screenshot and send it to him on Discord. Okay. So I can say yes to. Oh, I've already done that. All right. All right. So maybe we'll check just this one of these other ones. This Flappy Bird one. I don't have the LED display, but I'll be able to put the waveform on the scope. And we should be able to see the scanning happening.
Oh yeah, I see. I thought it was VGA for some reason.
Yeah, me too. I think there's another. There might be another Flappy Bird on this, or another shuttle that also has.
Okay. So I know there is also a design in here that it's an analog design, but like you have an analog design and then a digital design, which are actually completely separate. Like they don't really talk to each other. They just put them on the same tiles because they wanted to test something purely analog and something purely digital. And so you have like the digital part, which is I think some VGA game, and then some op amps or something on.
Okay, that's looking quite good. We've got these offsets happening on the different pins, and we should also see them on the bidirectionals, and it looks like they're inverted. So I don't actually know what to expect there, but
So which pins are you probing now?
That's the first pin of the output and the first pin of the bidirectional.
Okay, so there should be like one pulse of one positive pulse of one and then one negative pulse on the other, I guess. I can't really see your screen or that. Oh wait, yeah, okay.
I can take another capture now.
Can you put your screen capture larger on the video, because it only occupies a small area in.
Yeah.
in the stream. So there's a lot of area that's not used.
Yeah. I was having a mess around with that earlier. Okay, let me post this into the TT06 channel. Okay, cool. All right, so let's move on then to talk a little bit about the analog stuff. So I'm not going to recap too much now because we've already done plenty of streams and recordings about it in the past. So if you're interested in how that stuff works, then check the chats that me and Sylvain have done before. I can maybe just show this one slide though. Just my ORConf presentation. Just looks like I've got fairly crappy internet at the moment for some reason, or the computer is having a hard time. Here, I think this shows it. So if you go to Tiny Tape Out Runs, you see the green designs and the green mucks. This is what that actually looks like. And so this is the analog mucks in here. And one thing to notice is that you only get these little switches if the design actually needs them. So if it only uses one output, it just gets placed one to reduce the loading on the output wire. And then we have these transmission gates here. And this is what was plotted for the frequency response of those gates. And then on top of that, we also have the pin parasitics and the frequency response. And then the other big issue is that we needed to get sorted was the power gating. So the design is not powered unless it's turned on. That's the true for all of the designs now. So one thing that would be nice to have a look at is the analog loopback and being able to see this transmission gate in action. Is that something that you have available to share with us, Sylvain?
Wait, which part? I mean, I thought we'd do it now.
Yeah. Yeah, how do you want to do it?
So, do you have the UFL cable and stuff? Right?
Yep.
Okay, so we can just select the loopback projects. So one thing is that at the moment the commenter doesn't display the analog pinout, so you need to go on tinytapeout on runs and then actually look it up. So for analog loopback, it's going to be project 494. And we see that A0 is going to be connected to A5, for instance.
Okay, like
so
here.
UA0 in your project, which is the pin in your project, is going to be connected to the external pin on the PCB,
okay,
labeled A5.
Yeah. And we're just so when we enable this design, we should just expect to see 0 shorted to 1. So we should get a connection between A5 and A0 on the board.
Yes, exactly.
Okay.
So you need to connect one UFL to basically the signal generator output of your scope. maybe don't connect it to the scope yet, because I don't know if your scope is the same as mine. I mean, I know it's not, but I don't know if the UI is the same. But I know that when I want to switch to the wave gen, I click the button to go through configuration that enables it at the same times, and it starts sending signal with whatever configuration it had before, which usually is not what you want.
Yeah.
So I leave it disconnected until the moment I have downloaded the configuration, and I'm sure that I'm gonna send the signal that I want to send.
Okay, so tell me let's use these first two. Tell me again the ones I need to connect them to.
A0 and A5.
Can you see this on the screen?
No, I just see the corner where it says open source hardware.
You can remove this one. Is that better?
No, lower it. Yeah, a little more still. Or point the camera up, but okay, now it's better. Like it's in frame and centered, more or less.
Okay. So this one, tell me again. Sorry, I've already forgotten.
A0 and A5.
Okay. Do you know how many times these connectors are good for?
I think the male one are rated for pretty high. The female probably less, because they are the one with the bendy part. The other are really just metal studs.
Okay.
Like there's really nothing to them.
There's A0 and here's A5. Okay, so you want doesn't matter which way around these go then, does it?
No, it's purely symmetrical.
Okay, so I'll put this other one in the back later.
Yeah, UFL female are rated for 20 mating cycle.
All right, so you want the wave generator on.
Yes.
What shall I put on there? A square wave?
Yeah,
Sine
sure.
wave?
I mean, the square has lots of harmonics, so it's gonna test the frequency response a bit better, I guess. But ideally, once we get the basic setup, we should set up a sweep.
Okay. Okay, so this is 500 millivolts peak to peak with an.
Yeah, maybe try something a little lower so that we can change the offset. So maybe something like 300 millivolt peak to peak with a 150 millivolt offset.
Okay. So that should be on now. Can I plot it? It's not a reference waveform, is it?
No, I don't think you can see on the scope the output that the wave generator is setting.
Okay, I guess I could use it like a T splitter.
Yeah, you need a T and then connect it to an input if you want to do that.
Whoops. Gen out. Right, gen out. And then that can go here. There we go. Okay, so don't know if you can. Maybe I'll put this scope back. Oh damn! I don't. Yes, I can't really fix this easily at the moment because I don't have an easy way of connecting that scope any other way.
Somebody in chat was asking the maximum current. I'm assuming you're asking the maximum current through the analog path. It's rated for 4 milliamps. Although it's mostly, it's in the worst case, so the chip at 95 degree and it's meant to hold indefinitely, which means that if for some testing you want to pass a little bit more current than that, it's probably going to be fine. At some point, depending on the chip availability and how much extra we have, I might actually do some testing on the max current and see where it burns, basically. But it's obviously destructive testing, and we don't have that many chips. So,
okay, so that's looking okay on the scope. What's expected?
Yes. So
now I'll connect this this extra wire.
Output. Yeah.
Oh yeah, we got something. Okay. I'm going to move the. I think because the Wi-Fi is.
You need an HDMI capture card for your scope.
Yes. Because the Wi-Fi is so bad, I'll probably. Tell me when the camera is in the right place for the scope.
Point it up slightly. At the moment, we're centered on the connectors, so still more up. Yeah, that's okay. That's okay. We can see the screen, and yeah. Are they at the same vertical division?
Yes, they are. Yeah. That's terrible glare on the screen. Is that any better?
Yes, it's better now. Okay, no, it's worse. Because I guess what was better was you covering the. That's terrible.
Oh my God. And then as soon as one light is kind of out of the way,
the other is in
the other is in the way.
Yeah.
That's better. I'll be in the shade so the scope can be in the sun.
Yeah. Okay, it's
so it's a little bit smaller.
Yes, it's a little bit smaller. Honestly, it's a bit smaller, more than I would have expected it to be. What frequency are you sending?
Period is about 1 millisecond.
Yeah, that's 1 kilohertz. That's nothing. Why would it be so much lower? Because I mean, at that frequency, like all the capacitive loading shouldn't matter much because it's gonna have time to charge, which means that it should be like purely like resistive loading. But the input of your scope should be 1 megohm, which shouldn't really affect it all that much.
Is it because could it have anything to do with the fact that we're not using scope probes anymore? Like they're not the 1 to 10 things anymore.
I mean, at that low frequency, it shouldn't matter because even like the loading from the scope is gonna be more important, but that's mostly capacitive, which at that low frequency shouldn't matter. And the resistive loading of the scope should be like 1 megohm, I think, or something like that. Let me check on that scope what it is, but it's an HD3 something, right?
Yeah.
HD3. What is the rated loading of this? You did cut all the 1K, like you checked that they were cut and they didn't make contact anymore, right?
Yeah, I checked them just with a diode check. I didn't actually measure resistance.
No, but you checked after cutting the trace that they
Yeah.
were not connected, like the jumpers were not connected anymore.
Yeah.
Okay. Can you take a screenshot to maybe try to read the number so that I can see how much? I mean, it's not that reduced. Okay. So we're talking 210 maybe? And the other is 300 is the source, right? So
We could try another pair.
yeah, you just need to disconnect and reconnect.
Yeah. I might try just changing the frequency, just so we can see how that changes as the frequency goes up.
Yeah.
Oops. Frequency 10 kilohertz. Okay. But yeah, it looks like something is a bit awry though, because this is only 100 kilohertz.
I mean, I would expect it to definitely, because you're sending a square wave,
Yeah.
it's definitely going to round
Yeah.
pretty quickly. But and also the capacity, as you increase the capacitive loading of your scope and the cable and stuff is going to matter more and more. You'd want an actual scope probe at that point to reduce it. But I wouldn't have expected it to be so much for 1 kilohertz, because at 1 kilohertz it's really low.
Okay, well, this is what it looks like at 100 kilohertz.
Okay. Yeah, the capacitive loading of the scope itself is like 24 picofarad, which is, and then you have the coax cable, which, I mean, it's a conductor inside a separated by the electric, so it's basically a long capacitor.
Yeah. Okay, well, let's try another pair then. So if we try 4 and 1.
What's interesting is that it seems to rise much faster than it's falling.
Any tips for getting these off?
Yes, you need like a small plastic thing, and then you push right underneath where it connects to the cable. You try to push vertically.
You push it?
I mean, you push it from underneath, like so you put a plastic thing between the board and where it mates to the connector. Then you twist it to like lift it as close as possible to the connector.
I've got a little plastic screwdriver here for adjusting scope probes.
Yeah.
So I got it off okay, now I can't get it on.
Daniel is asking if it's possible the scope is in 50 ohm modes. No, if it was, you would see much more attenuation than this because the expected resistance is in the through the loopback and the analog switch. A 2 analog switch is probably around 500 ohms, so we would see the signal attenuated like 1 to 10, which is not what we're seeing here. We're seeing like from 210 to like maybe 70% or something, like 0.7.
Do you see something quite different now, though? On that other...
Yeah, no, it's more symmetrical actually.
Yeah.
But it's also reduced in amplitude. Did you switch to another pair?
That's switched over onto pins 2 and 3. As in A4 and A1.
Wow, there is actually quite difference between the two. I
Yeah.
wouldn't have expected that.
Yeah, well, it could be. I did find those pull down things very difficult to cut without damaging other stuff. So could be that they're not fully cut. I can check that later. Yeah.
Yeah, this one is way worse. I mean, it's interesting. I mean, I know that I didn't check on the analog loop back. I did check. I mean, I checked one pair in the analog loop back and one pair in another analog project, and I measured about the same thing. So I don't expect that much variance between them, especially there where they are right next to each other.
I can adjust this offset and watch them go up together.
So DM in chat. No, the direction isn't important. They're both they're going analog to analog, so it's literally just connecting two analog pins. So you're basically coming from the pad, going through one of the TT06 analog switch, then directly going back to another TT06 analog switch, and then to the pad.
So I should be able to raise this all the way up to 1.8 volts, right?
Yes, you need to change the common mode though, so that the input signal doesn't go above 1.8. Where is your ground for 1.8? What is your ground for green?
Sylvan.
Yeah.
This board isn't even plugged in.
What do you mean it's not plugged in?
It's not plugged in and the analog design isn't selected.
You didn't select the analog?
I didn't even plug it in. I unplugged it to do this wiring up and then I didn't...
Oh, okay. Interesting that it conducts anything at all.
That it did anything at all, yeah, okay. So let me... God damn it.
How does that work? I mean, there is some capacitive coupling, but not that much to pass signal that thing. But I'm guessing that the signal you're injecting is basically starting to power things up because you basically have...
Oh, look at that. That's totally different.
Yes. Wait.
We'll just pretend that none of that happened.
But your scale are not the same on both channels then.
I changed this top one to there we go. Now
okay. Okay, yeah, that looks
all right. Now
what I would expect.
Yeah, now we're getting somewhere.
Because you can try if you disable the analog, select any other project, it should disappear almost completely.
Okay. Oh, yeah, look at that. That's way better now, obviously.
Yeah, that's more what I expect. There's basically no difference at that frequency.
Yeah, so that's now at 2 megahertz.
Yeah. At that point, you're going to start needing a probe because the capacitive loading of the 20 picofarad, that's something like, yeah. I mean, at that point, it's not going to matter much. If you switch to a sine, it would still be the same amplitude. You can actually try to do a sweep. Like your scope should be able to do that by itself.
Yeah, let me select a different projects now, though, like the factory test. All right, yeah, there we go.
Yeah, that's what I expect when the switch is off.
Hey, Mithro's here. Hi, Tim.
Hey, hi, Tim.
Okay, but no, I'm not seeing anything on the output anymore after selecting and unselecting the factory test.
No, you need to select analog loopback. Oh, wait.
Oh, yes, not the factory test. What's the analog factory test?
Analog factory test is, well, it has a loopback, but on different pins. But it has a power sense. And it also has like basically a dummy load that allows to artificially load the power supply. So we can generate like a 1 milliamp control current. And that allows to test the power delivery network so that we can see by how much the power supply that the project sees, drops from 1.8 volt if it's drawing 1 milliamp.
Okay, but that's great. So we've got much more like what we're expecting now. Let me grab a screenshot. And like Daniel says, it doesn't work if you don't turn it on.
Yeah.
So I guess that was just like only capacitive coupling then.
Yeah, but it must, because for it, as you see, like if you turn it off, if you turn off the project, then you have only the capacitive coupling, and you really not seeing anything because the capacitive coupling is tiny. It's in the femtofarad range, which means that it's only gonna pass like gigahertz types of frequency, not a 1 megahertz signal.
Yeah.
So what I'm guessing is that your project was basically, I mean, the signal that you were injecting was basically starting backfeeding the logic through the protection diodes.
Yeah.
And I have no idea what it was doing, but apparently something.
Okay, so that is looking way better. I can just put the actual screenshot, which is a clearer image now on the screen there.
Yeah.
Okay, what else do you want to try on this design then? Or should we move on to have a look at another design?
Oh yeah, we can have a look at other designs so that we go and do some other things. You can load your DAC or your oscillator.
Okay. So, yeah, great to see the DAC working. So that's gonna, I need to come back. Oh, but we should, let's just leave a feedback.
The DAC output is gonna be on A4. Oh, you're already on it. Just make sure to if it's the pin connected to your signal generator, make sure to disconnect it before switching on so that you don't inject something in your DAC output.
Okay.
So A4 is what you need to connect it to the scope.
Okay, so A4. Okay, A4 is this one. So I need to turn off the wave gen.
Why do you still have a signal on the scope?
Maybe I did have that design selected. Okay. Wasn't expecting it to look quite so loopy.
Yeah, I'm guessing. What frequency is that?
Can turn this off as well. That is great. That is 10 megahertz.
Yeah, so the loading from the cable and the scope is just too much to accurately represent the sharp transition and stuff. You probably would have better result if you can use a scope probe and just disconnect the cable and then probe the actual pin. I mean, you can probe it's easier to probe the jumper because it's a big landing pad.
As far, now that I've set it to 1 megahertz, it's no longer doing anything. It's a bit odd.
Yeah, there's some problem in the Python console, so I'm not sure what it's doing, but
reload it.
Oh, that is not working.
That's connected to something totally different. TT06. 03.5. Shame we've kind of gone a bit backwards in our reliability with this new SDK and Commander combo.
Yeah, it's a bit experimental.
There we go. Replug worked. And I got attribute errors again.
Yeah, why does it say in set clock hertz? You can try to do a REPL to do it by just to type the command yourself. There's an error. I don't know how to manually configure the pin on the. I'm not sure why it's doing that. Maybe you can select just set the 10 megahertz clock on the chip ROM or something, and then switch to the project.
No, it's broken straight away.
That's weird. It was working like you used it for other projects, right? So
yeah. You sent me the link to that, didn't you? Nope.
how?
Attribute error, nothing.
Yeah. Yeah, Pat is asleep. Yeah, I have no idea. I really don't know the commander or the firmware that well. but it's throwing on every single design. So
I'm going to shut this whole browser window, which probably won't do anything, but it's worth trying.
Okay. Hopefully you didn't have StreamYard in it.
No, that's on the other one, but that also, I guess I could also try that. And
No, better not.
well, if you're connected, wouldn't that be?
I don't know. I have no idea because
And
you're.
what is using? Look at this. Chrome is going crazy. I guess that's the StreamYard one, though.
Ah, yeah. Oh, wow.
And this time I'm getting a failed to execute request on port. Now it works, but with the wrong shuttle. Damn. Well, I don't really know what to do here. Kind of, I guess I could try ignoring the commander and do it all through the SDK. But I doubt that's going to work because can't even quit this shell now. Because the new commander is doing everything through the SDK, right?
I am not, honestly, I don't know. I think it's doing more, but I'm not sure if it's doing everything.
Something is very wrong with this connection. I'll try replugging it again.
Okay.
It's got the wrong project again.
Yeah, but that's what's weird is that the support for 3.5 was even removed at all from that SDK, as far as I knew. Are you sure you're connected to the right board?
Yes, because when I now pull the cable out, it's going to kill that connection.
And did you update to the latest?
Yeah.
To the RC3?
Yeah.
Okay, I thought they had updated the MicroPython version to 1.24.
Now it's doing something totally different.
TT SDK v0.0. What?
Maybe it's worth flashing it again.
Yeah. DM, I don't know what you mean by SDK1 sequence.
Okay. That looks different.
Yeah, no, it says MicroPython 124.0.
Soft reboot. Okay, and it picked it up that it's Shuttle 6.
Does the Raspberry Pi Pico have something like a double firmware where it, falls back to an old version if something goes wrong in the current one or something like that? I don't know. R2R.
Yeah, I don't even know how to select it. I rely so heavily on the commander.
Yeah. Well, maybe the commander will work now.
Yes.
Yeah, I don't know if those still exist in the new SDK. I know a lot of stuff has been reworked, so you might have to change your script with the new SDK. But I guess there is a reason it's called RC and not V2.
Okay, so that's now looks like it's enabled the DAC and set the clock to run. Although maybe it doesn't actually select the clock. Okay, now we're not getting an attribute error.
Okay, that's good. The scope did something, but I can't really see. You might need to change the horizontal scale because you're much slower now, but or the trigger point.
Oh,
Yeah. Okay.
okay. And that's up to nearly 1.8 volts.
Yeah, so it's still a bit rounded at the bottom, but that's because, yeah, the capacitance of the thing. If you use the natural scope probe, you would see a more
Okay.
sharp signal.
Yeah, but that's still awesome. I can if I slow it down though to like 100 kilohertz. Now I should get a nice sharp bottom. Yes. Ooh, look at that sharp bottom. Yahoo! Hooray!
Actually, can you zoom on the oh wait, switch in the acquisition mode of your scope? There should be a high resolution mode.
A high resolution mode.
Yeah. So do you have a button called like a acquisition or something like that?
No.
Damn it! I don't know the interface of the HD3.
What does it do?
So basically, because you're sampling a low resolution signal, you can both average several samples, and that reduces the noise, and that allows you to see like much more detail. And I wanted to see if you could see the steps of the DAC, because it's an 8-bit DAC, while your scope is capable of 14 bits of resolution. So
Yeah.
you should be able to see the individual staircase of the DAC.
I've got a I can turn it to from normal acquisition mode to averaging.
Well, that's the beginning. You can try that first.
Okay.
Okay, try to zoom vertically on somewhere. Okay, and horizontally as well.
Yeah.
Can you see some steps?
Yeah.
It's okay. Yeah.
Aha. Cool.
So you can see the individual steps
Yes.
of the DAC, and then in theory you should be able. I mean, it's a bit more setup. I don't know how to do it there, but you can set it up to measure. Is every step the same height, and then you can measure the integral nonlinearity of your DAC and stuff like that to see how well matched your various resistors are. You can actually try to look around the middle.
Yeah,
Basically,
that's where the that big.
yeah, because that's where you have the MSB switching from all the LSB to a single resistance, and usually that's where you're gonna see the biggest weirdness, I will say. So it should be around 900 millivolts or something. I can't read the scale from here, but
Yeah, it's doesn't look bad for a crappy R2R. That's pretty zoomed in onto the middle.
yeah, I don't see anything really jumping out there.
Here's the on the. Let me solo this, or maybe. Whoops. There we go. There you go.
Yeah, I don't really see anything. Like it looks pretty good to me. Like every step is.
Let me get a screenshot of it. It's
I don't remember. Is the output of your R2 DAC buffered in any way, or is it the raw output of the resistor ladder?
I think it's the raw output.
Okay. So yeah, in addition to the impedance of the analog subsystem of tiny tape out, you also have the output impedance of your DAC. I don't know what kind of resistors you used, but
Nice. Okay, and we can check maybe another couple of.
yeah, you can check your oscillator. You had an oscillator on there.
Yeah.
Relaxation oscillator number 516.
I'll grab this other image. And what were we on? We were on that's on
It's a
100 kilohertz.
Yes.
And I can drive this also directly from the RP2040, so I could potentially do something fancy like load an arbitrary waveform and then drive that out.
Yes. You can do audio output or something. I mean, easily, because at 100 kilohertz. You'll need to buffer it to actually hear it, but...
Okay, so...
You can feed the output to another TT6 board, which is running the DAC from Karsten.
Yes.
And then you can see how good a loop back you can do between the two.
Yeah, I do have the problem. I can't do that here because I've got a problem with that QFN socket. I couldn't get it to work. So
No, because you only tried with the old SDK and stuff, and that wasn't working even with the chip.
Oh, you think maybe that would work if I? Okay. I thought I did try that.
Yeah. The only thing is that because his ADC expects a differential input, so you need a bit of analog tweaking to turn your signal into something that it's going to read. But
okay. And so this is
so output is going to be on pin B4.
B4. Okay. Let's
and also on the IO0, like the digital IO0.
yeah. Let's try that first then. IO0.
Yes, Mitro, if we slowed it down more, then the step would appear more square because they would have time to charge. Here you can see on the shape of the steps that it barely has the time to reach the new value as we input the new one. So if you slowed it down, it would be more square. Other ways to make it appear more square would be not connect directly to the scope through a cable, but actually use like a low loading probe, like a 10-to-1 probe directly at the pin, or just buffer the output somehow. Because as I said, there is both the output impedance of timetable itself, but also the fact that an R2R DAC, because it's using resistor, has a fairly high output impedance naturally. So usually you'd want to buffer it with an op amp or something afterwards.
Okay, you said I just saw the digital output, so that's a good sign.
Yeah. You can put both so that we can see the phase shift between the two.
Yeah, and then remind me again what the
B4.
the output is? B4.
Yes.
B4.
Yeah, actually, yeah, we have to see because I remember from testing it that just probing the pin changes the capacitance that is seen by the oscillator, which means it changes the frequency of the oscillator itself, just plugging it in. And if you load it too much, it just stops oscillating. So if you stop seeing oscillation on the scope when you plug the probe, then you're probably loading it too much.
Okay. So on 2, I do see something very low amplitude.
Do you still have the digital pin probed?
Now I do. Hold on. Yeah, that's the right one.
And you don't see any output on it anymore.
I'm not sure why it's. That's 1. I can see it's doing something, but there we go. But it doesn't seem real.
No,
that's just noise, isn't it?
Coupling or something. Yeah, it's too low. I mean, the output of the digital pin should be like 1.8 volt.
Yeah.
But I'm
It's,
guessing that, can you try to disconnect your scope, the cable to the analog cable to see if the digital signal comes back?
disconnect the analog one.
Yes. No, that's not enough, apparently, to make it come back. It should oscillate around 1 to 2 megahertz, so you can set your horizontal
Yeah.
scale appropriately for that. What
Let me
was
just
yeah.
let's just try the factory test again. I need to set the clock as well, don't I? Well, I should be able to do it like that. Okay, yeah, that looks like it's working. Although I'm still seeing just like a...
Yeah, is your scope probe? It's because it's the green one and you are putting it on the yellow input. It's not compatible.
Yes, it's having a problem because of my color blindness.
Are you colorblind?
Yeah, but not with yellow and green, so...
Ah.
Yeah, on the output pin 1, yeah, it's got this like 100 millivolt noise sine wave, but only on, and on 3, 4, 5, 6, 7. Let me get some, turn on the auto clocking. Let's see if this causes it to fall over again. No, not this time. What the hell?
Your trigger level is probably too low, and so it's triggering on random things.
There we go. Okay, well that looks okay.
Yes.
I should really have soldered those headers. Okay, so which one are we on? Relaxation.
Yes, 514, I think. 516, sorry.
Set. No errors or warnings. Okay, but nothing on...
Nothing on the digital output. Can
No.
you try to disable? So at the moment you still have the UFL connected to the SMA and the SMA connected to some cable, right?
Yeah.
Can you try to disconnect the cable from the SMA socket?
All of them or just one of them?
Just the one connected to B4.
Oh, because it could be loading so badly.
Yeah, exactly.
Yeah, there you go. Look. Yeah, there you see. Yeah.
There you go. So the cable loading is too much. So you can probe it with a scope probe because that will reduce the loading dramatically compared to the cable.
Okay.
But you can't just connect it to the cable.
Yeah. Haha. Cool. Okay. I'm just probing this to the center of that SMA then. Whoa. That's weird.
Yeah,
Maybe,
you seem to have like some. You're probably picking up some random noise in your lab that couples into what you're probing. I'm guessing your ground connection is probably a bit long or something. In the trigger menu, you should have like a HF reject or a noise reject, something like that.
I got a send email on trigger. Conditioning,
I don't know.
setup, edge, auto, conditioning, HF reject,
HF reject, yeah, try that.
noise reject.
Okay, try to disable HF reject because maybe it considers. But okay, it's more stable now. But
What the hell is going on here? It's like it's the ground's not connected, or the ground's just connected to the ground on the board. Should be fine, shouldn't it?
yes, it should.
It's totally different though if I do it that way.
You can try probing the little jumper on the side that you cut. I mean, on the side that's still connected, obviously.
There we go. That's better. But yeah, there's that weird kind of ghosts. Terrible signal quality.
Yeah, but that's probably because you have like a long cable that's basically an antenna, so it's pinging up whatever. If you disconnect the UFL and probe the little pad on the jumper, it should look better.
Okay.
What you can do also is just put, with the little hooks that you put at the end of the probe, you can put a probe attached to the output one, because you can hook behind the PMOD headers, where they connect. You can just put a hook on that with one of the probes, and then that gives you like a very clean trigger that you can use, and then with the other probe you can probe the oscillator.
So use one scope probe for the digital.
Yes, and then and you trigger on that, and then the other for the analog probing. Then your trigger doesn't depend, and you will actually see also that when you plug your scope probe on the analog pin, you will probably see the frequency change.
Yeah. Okay.
Okay, I think you moved either the scope or one of the light, but half the screen is reflection from the okay, it's better. Yeah, I can see enough.
Yeah, I can see that happening clearly when I probe it.
Yeah.
There we go, though. All right. And that's probably as good as I can get it. Well, that is terrible. I sincerely apologize to anyone watching this on the how bad that scope looks. Can I enable the screen again? Need to definitely work out a way of getting that scope.
Yeah, I mean, in theory, because you're using the get image, but in theory, you can click on control instrument, like on top.
Yeah.
And then you will have like a VNC kind of connection to the scope that should be live. But of course, depending on the quality of the connection, that might, I don't know.
Okay, so let's take a look at how good my documentation is. Oh, I'd totally been forgetting to do the stamping thing. Okay, so if anyone wants to see the layout, that's the layout. And then
it's a massive, like the amount of space taken by those capacitors is.
make approximately 2 megahertz. Okay, and what do we have on here? From peak to peak is 200, 400, 600, 800, 900 nanoseconds.
Yeah, something like that. So it's roughly 1 megahertz.
1.1 megahertz. Cool. Okay. Anyway, did I put a waveform here or no? I wonder if I can, how hard it will be for me to load this up again. So yeah, that's I remember it now. So yeah, the output just goes, so the digital output goes through that inverter, but the analog output is not buffered.
Yeah, and when you loaded it too much, like we could still see an oscillation on the analog pins, but it was probably not with enough amplitude to actually trigger the digital buffer. So it was just stuck one way.
Yeah. Is this doing a multi-corner? Okay, so that was what I was expecting the waveform to look like.
Yeah, and it is roughly 1 megahertz. So I'm not sure why the doc says 2.
Yeah. Okay.
Because it's roughly 1 microsecond per oscillation from what I can see. So that would be 1 megahertz.
Yeah.
So it does match. I don't know why the README
Yeah,
said
I
it
need to
expected
update
2
the docs
megahertz.
then.
But,
Yeah. Yeah. Let me grab a screenshot of those 4 graphs. Yeah, so that's 500 nanoseconds to 1,700 nanoseconds. Yeah, 840 megahertz-ish. Okay. That was cool that I was able to load it up and simulate it again and get the results back.
yes, it still works.
Yay! Okay, right, it's 2:30. So I think, is there anything else you wanted to have a look at?
No, because I think the other would be a little hard to test without the test board thingy. Because I had also like maybe look at an op-amp, but you need an op-amp. You can't really just look at the result. Like you need to feed it
Yeah,
some
well,
stimuli and test.
yeah.
So it's harder to test like that.
Oh, you've been submitting tests as well. That's great.
Yes. I submitted a few results for the stuff that I tested, and not necessarily everything. I mean, some of the stuff I also don't know if people might want the surprise of to know if their design works.
Sure. Yeah. Yeah.
So I didn't want to publish results for.
I think that's both my analog designs working though.
Yes.
So that's good. Oh, Alexander's here. He wants to. Hi, Alexander from the Philippines. Project 101, the Pilipinas one. Okay, so let's finish off with that, and then my plan is stream again in the afternoon with Pat and take a look at some SDK stuff. I also need to eat lunch. So let's do this as the last test, and then hang up the stream, and then do another one in the afternoon. Oh, that was the wrong one to close. Oh. Did you see? I saw it did something then, and now it's gone back into its broken mode. This.
I think that's when you have two different windows open on the same.
No, it's detecting TT04. I wonder if we get the clock problem again. No.
Yeah, TT04 is when it can't read the ROM.
Okay. Yeah. All right. I will replug it. Is the screen on at the moment? The webcam on at the moment?
No, it's not.
Okay.
At the moment, you can see, yeah.
Let me add this then. Okay, come on.
Yeah, perfect. And we can see the.
You can do it. Come on. Yes, Tiny TT06. So what was it? Pilipinas 101 by Alexander. Select. Set. Oh, I do see it doing something. It looks like we're missing a segment though.
Yeah, something is strange. I know I tried by clocking it manually, and that seemed to work fine because I posted the results.
Oh yeah.
LH.
Maybe I've blown up this board, or I've got something going on wrong with it.
Try resetting it, by the way, because I don't think it does that by default. Maybe just in a weird state.
I don't think it's doing what we're expecting anyway.
Did you reset it? Or?
Yeah.
Oh, okay. Yeah, it's missing the top segment, I think.
Yeah. Oh, you've already checked it anyway.
Yeah. Because that should be a P. Oh, your board doesn't have headers.
No.
Okay.
That's not doing anything.
Have we seen that top segment lit up anywhere before? If you run the factory test, does that top segment light up?
No.
No, it doesn't. Okay, so there's a problem with your board or the chip. You can do a diode test on that. Maybe I screwed up my soldering. That would be embarrassing. But I'm pretty sure I tested it.
But isn't that output pin? Isn't that top segment pin 0 though?
I don't know.
I'm sure I've seen it working. Yeah, there's 0, 1, 2, 3, 4, 5, 6, 7. So I think it might be actually this LED
Ah, okay. You see something on every segment.
on every pin. Yeah.
Okay, so there might be something wrong with the
board.
Okay.
Okay. So I don't think I will try the other board and reflash the firmware and everything like that because I've got to eat lunch in a break. So Alexander, I think, but Sylvan's already checked your design. Looks like it works, but I can check it again on a different board with a working 7 segment. So yeah, thanks for tuning in, people, and thanks Sylvan for joining and helping with the analog stuff, and great work on all your getting all the analog stuff working in the first place. It's amazing we have that capability now.
Yeah, looking forward to what people will do.
Yeah, are you going to hang out on this afternoon's session, or you got something else you're doing?
I'll probably be in the YouTube chat, just listening in, and yeah.
Cool. Okay.
Okay.
So maybe see you all later on in the afternoon. Otherwise, I'll be editing this up together to get like a best of. And then we're still going to, for the people who submitted a Tiny TT06, we're still planning on doing like a group bring up party. So if you're interested in that, keep your eye on the Discord or the emails. Otherwise, have a nice rest of your day.
Okay.
Cheers.
See you.